Hello, everyone. Welcome. Thanks for joining. So this is a little overview of our work on automated fact-checking over the last couple of years. My name is Emmanuel Trummer, and I am assistant professor at Cornell University from the Cornell Database Group. And this is joint work with some amazing collaborators, among others at Google and at Eurocom in France. All right. So maybe a little word on organization. So by default, I have muted everyone, but please, if you have a question during the talk, please let me know and put a message into the chat. If I see something, then at the next opportunity, I will respond to it. And also towards the end of the talk, there will be some opportunity to ask questions. Okay. All right. Good. Let's get started. So this talk is going to be about automation and fact-checking. And a priori, there's many ways in which automation can help to speed up or to make fact-checking easier. For instance, before we even start checking, there are so many claims that we could verify. Maybe we want to pick out the claims that are most check-worthy. And there's a couple of very interesting works on the topic how systems can automatically figure out which claims are the most interesting to verify, for instance, in the context of the claim buster system. And also after a fact check has been produced, we might want to link future claims back to existing fact checks if that is possible. And again, there is some very interesting work on that topic as well. Now, the topic of this talk, however, will be what I would call like the core of fact checking, so to speak, which is essentially given a fresh claim, decide whether that claim is true or not. That is going to be the focus of this talk. And I'm going to present a couple of tools which at least partially automate that process. Now, I'm going to focus on scenarios which we call data-driven fact checking, where claims can be verified using machine-readable source data. So the high-level process is what you see here on this slide. If we have a claim, we want to map that claim to some relevant raw data and to a mathematical formula, such that evaluating the formula on that data allows us to verify or to refute the claim. So essentially, if the formula on the data checks out, means it evaluates to true, we consider the claim as verified. If the formula evaluates to false, we consider the claim as refuted. And little word on terminology. Instead of formula, the more technical term would be SQL query, which can be interesting for the developers among you. But in the following, I'm gonna continue using the more generic term formula. All right, good. So we assume that the claim that we want to verify is given in a natural language. So the main challenge is gonna be to map this claim to a relevant data set and to translate this claim into a mathematical formula that accurately can represent the claim, right? So those are the main challenges. And in the following, we're going to see some tools which allow you to make this step more easier. All right. Now, this scenario might seem a little bit abstract. So let me make it more concrete by giving you a few use cases. And the tools that I'm going to present in the following have actually been applied to those use cases. First of all, meet the International Energy Agency. And that is a picture of the headquarters in France, close to Paris. The International Energy Agency is an intergovernmental organization which has currently up to 30 member countries. It was founded in '74, shortly after the oil crisis. And its mission is to inform the member countries on developments in the energy sector. So their goal is to inform policy decisions with statistics about the energy sector and they disseminate those energy-related statistics in the form of huge technical reports. And here you see only 2 pages out of a report like that. And now in red here, I have marked up the claims that appear only on those 2 pages. So those are statistical claims that are related to energy consumption. Could, for instance, be a claim about the energy demand in a specific region that grew by a certain percentage within a certain time frame. So often those claims are associated with some kind of numerical statistics, right? So I mean, this is just 2 pages. The entire report has something like 600, 700 pages, which means that we are dealing with many thousands of claims. And as you can imagine, for the International Energy Agency, it is absolutely crucial that each and every single one of those claims is absolutely correct. Because those claims, they form the basis for important policy decisions, and in terms of reputation, it would be devastating if those numbers are not accurate. And that is why the International Energy Agency currently employs an entire team of fact checkers, which go through each of those claims one by one. Multiple fact checkers look at the same claim in order to be really sure. And this process, in order to verify all those thousands of claims, even with an entire team of fact checkers, that takes weeks to even months. So this means a huge investment in terms of time and in terms of money. And this entire scenario generally matches the scenario of data-driven fact checking. So here a claim could be something such as, in 2017, global electricity demand grew by 3%. And then we could map this claim to data that IEA, the International Energy Agency, possesses. Here, for instance, we are talking about the growth of the electricity demand in 2017. So we probably want to compare the demand in 2017 to the demand in 2016. So we might need 2 data sets, one about 2017, one about 2016. And with that data, we could express this claim by the following formula. It could be something such as demand in 2017 divided by demand in 2016 equals 1.03 in order to account for the 3%. Now, currently, the International Energy Agency is doing this with a team of fact checkers, but we are currently collaborating with them and with Oilcom in France in order to automate that process, in order to make it easier and faster. And later I will present a tool which has already been applied in that context. Now, to give you another use case, you have probably all heard about the term infodemic, which designates the spread of misinformation around the coronavirus. And there is many types of misclaims around the coronavirus. At least some of them are misclaims about statistics, talking, for instance, about the number of cases in specific countries or specific regions, or the recovery ratio of the coronavirus, perhaps compared to other diseases. So there's a lot of misinformation out there, and that inspired us to put a web interface online which allows people to enter statistical claims about the coronavirus in this box here. I'm going to show you a demo later. And then after hitting the check button, we translate those claims into formulas and evaluate those formulas on data from sources such as WHO or CDC. And we come to a conclusion about whether that statistical claim is actually true or not. And if users click the appropriate button, they can even get more details, and they can see which formula and which data was used to come to this verification result. All right, so here would have claims such as, for instance, France has more cases than the US, which one could verify by going to the data from CDC and using a formula such as France, like number of cases in France greater than number of cases in the United States. And if we achieve that translation, we can automatically verify the claim. So this interface is mostly automated, but every once in a while, users will enter a claim that the system feels not very confident about. So in this case, we bring a human into the loop and we ask users for feedback about how to verify the current claim. And over time, the system will learn from that feedback in order to become more accurate at verifying those claims. Now, this is just 2 out of many possible use cases. Other use cases, for instance, whenever you have a newspaper article in data journalism, you typically can verify it by using a data set. Whenever you have business reports, you can typically verify the numbers by using a data set, or if you write scientific papers, then the experimental evaluation section that is often based on a data set. And in all of those cases, we generally match the scenario of data-driven verification. So I'm only mentioning 2 concrete use cases, but there's many more out there. All right, good. So before we go any further, I want to show you a demo of a little tool that we have been developing recently. And here on this slide, you also see the most recent paper that we published on that tool on the Sigma 2019 conference, which is one of our primary database conferences. So let's see a little bit how that data-driven fact-checking helped by automated tools can look in practice. All right, just checking whether there's anything in the chat. No, good. All right. Now, the tool that I'm about to present to you is publicly accessible. If you Google for Cornell and fact-checking, then you should get a link to our website. And on that website, I'm going there now, you can find a link to the interface that I'm about to present. Here, the fact checker online demo. All right, I'm already opening it here. And now let's see what we actually want to verify. So let's take an article from the 538 website. And I think many of you might know the 538 website. It is generally a data journalism venue. So the articles there often analyze and summarize data sets. All right. Now here we have an article that appeared a couple of years back, and it essentially analyzes a data set about the preferences in different countries for different drinks. And it contains a lot of statistical claims about the data set, which we will verify in the following as an introductory example. So let's, for instance, see here, we have a couple of claims in this paragraph that I have just marked up. It is stating, Namibia is the world's biggest beer drinking country with 376 cans of beer consumed per person. In Germany, the average is 346 cans, and in the US, it's 249 cans. So here I essentially have 3 claims in those 2 sentences about the yearly consumption in different countries. Now, and it can actually be quite challenging to figure out which data set can be used in order to verify a given claim. Fortunately, in this case, it's quite easy because 538 often publishes a link to the data that an article was generated from. And that is also the case here. Here they have the link to the corresponding data set. So let's actually follow it and see what data we find there. All right, so here there's a data file drinks.csv. Let's actually open it. And this is a relatively simple data set to start here. You see that in the left column of this tabular data set, we have the country. And here in the next column, for instance, we have the associated number of beer servings per person and per year in average for the corresponding country. So in a specific row, you find the beer consumption associated with the corresponding country. And here we have the same thing for the other drinks. So this is a relatively small and simple data set, but I think it's a good example to get started here. All right. So Now I want to verify whether the claims in the text are consistent with the data. So first of all, I want to download this data set. Let's do this. And let's, for instance, put that here. All right. Drinks.csv. Downloaded before. Let's overwrite. All right. On the other side, I need to select which claims in the text I want to verify. Here, to keep things simple, I'm only copying 2 of those paragraphs. And now in our fact checker interface here, you have a couple of prepared test cases that you can try, but you can also upload your own data and your own text. And this is what we are going to do now. All right. So upload your own text and data. Here, I'm going to insert the text that I want to verify. And here I'm going to upload the data that I want to verify it with. This is the file that I just downloaded. All right, actually, that is a copy of the same file, but let me really use exactly the same file here that I just downloaded. Okay, good. And now I hit the verify button. So the analysis of the text and of the data set starts. It is very quick because this is a small data set. So verification is not very computationally expensive. Now, the first step is that I need the system which claims I actually want to verify. Now here the system has marked up in slight gray, as you can see here, those numbers in the text that might correspond to check-worthy numerical claims. But the system is waiting for me, the user, to verify that those claims should really be verified. For instance, here the first claim is about the beer consumption in Namibia. That can be verified from the data set, so I'm selecting it. Now the next one is about the consumption in Germany, so I'm selecting that as well. And here we have to yes, fine. Now this here, it's a number that appears in text and the system carefully marked it up as potential claim. But here actually, we don't want to verify that because here we are just starting an assumption about what constitutes one serving of liquor. Now the next one, however, that is a claim again about the consumption in Grenada, and finally a claim about the consumption in Russia. So now I have marked up all of those claims, and now I'm going to tell the system to start verification. All right, good. And that was also very quick. And now we see that those claims that I have marked up before, they're marked now in a slight green. And that means that the system believes this claim to be correct after looking at the data, but it is not 100% sure and it awaits my verification. If I hover over one of those claims, I actually get an explanation about why the system believes that this claim is accurate. The system shows me essentially a nearly natural language description of the formula that the claim was translated into. So here, the claim was translated into a formula that sums up the values in the beer servings columns for all the rows where the country is set to Namibia in order to verify these claims about the beer consumption in Namibia. And here I see if that query translates the claim accurately, the result is 376, and that is indeed the result that I find here in the text from the 538 article. So that seems to make sense. But let's have another look at the data set. So here I have the data set again. And here I have the beer servings columns, and here I have the countries on the left-hand side. And yes, in order to translate this claim, it probably makes sense to map that to the formula which sums up the values in this beer servings columns where the country is set to Namibia. That is perhaps a little bit more complex than we have to express it, because here actually for each country you only have one single row. So we could just say that we take the specific row, the single row where the country is set to Namibia, but that would require analyzing the data in order to find out that here we are in a special case where we only have one single row for each country. Currently the system doesn't do that, but it could be added fairly easily. But so just why we have a slightly more complex representation of the claim, but it comes back to the same thing. All right, So here the system believes that we are summing over the values in the beer servings columns for the rows where the country is set to Namibia, and that seems accurate, so I'm marking this as correct. And now it changes to a stronger green because now the system has our verification and it knows that this claim is actually correct. So now we have verified 1 out of 5 claims selected for verification. Now here we are quickly checking the interpretation for that claim, which also seems fine. This is for Germany. Now here, this is also fine. Let's see this one. Okay, here country is set to Grenada and we're talking about spirit servings. All right, so that refers to a different column in the data set, but that makes sense. And the same for this column over here. All right, good. So now we have selected all of those claims and we have essentially verified this document. All right, so this is a fairly simple data set with a fairly simple text. So in this case, one could still imagine it would be also fairly quick to verify those things by hand just by looking at the rows of the data set. But I wanted to start with a very simple example in order to get into that. Now let's see a more complex example. Let's have a look at the results of the Stack Overflow developer survey. And if there's developers in the audience, you might know that the Stack Overflow platform every year executes a survey among developers, a relatively large online survey, that asks them all kinds of questions about the tools that they use, about demographic statistics, and so on and so forth, right? And the results of that survey, they are summarized in an online report. One of them is published every year. Here you see the version from 2016, for instance, which is one of the test cases that we use. And here you find all kinds of statistics, for instance, about the occupation of the developers. Here, for instance, we have a statistic stating that 2.5% of all developers are iOS mobile developers, right? And this kind of statistic could be verified by looking at the raw data. Now, here we don't directly have a link to the raw data, but by Googling a little bit, you can find it fairly easily. Here you have all the Stack Overflow data sets from the past years. And now this is a significantly larger data set than before. It has something like 70 megabytes after you unpack it. So in order to save us some time for this demo, I have already downloaded the data set and here I have loaded it into a spreadsheet software. Now this is the raw data. Every row in this data set corresponds to the answers of one specific developer, of one participant of that online survey. And the different columns, they correspond to different questions. Now here there's questions about the region they come from, about the age they have, about the occupation that they have, and so on and so forth. You see lots of gaps here, which means that the survey participant didn't provide an answer for that specific question, but that is fine. And you see there's actually a lot of columns, right? Lots of questions that they asked, lots of columns, a large data set. And if you wanted to verify the claims in that text, just figuring out what is the right column in order to verify one specific claim, that would already be quite tedious in my experience. All right, so let's see how this tool can help us to deal with that. All right, so here, so we don't need to upload the data. You already have this as a test case, try on test cases. Here we have the Stack Overflow 2016 survey and some of the others as well. Let's select that one. And now we start verification. All right, now here the data and the text are significantly larger than before. This is why verification takes longer. Those who currently don't use a particularly powerful server, so using a more powerful platform would speed this up as well. Currently, the system is analyzing the text of the document, the structure of the text, the sentences that appear in that text. It's analyzing the data set, it's running tentative queries, it's evaluating tentative formulas on that data set, and so on and so forth. And all of that takes a a little bit of time. So I believe now it should be done pretty soon. All right, let's wait a little bit here. Is there anything in the chat? No. Good. All right, and now we are done here. Here we see a couple of statistics about the verification process. I'm gonna talk later about those statistics. For the moment, let's skip that and directly focus on the verification result. All right, so this is the text that we have seen here, right? Here, this is the start of the text that we see here. Okay, copied into this interface. And it already starts with a claim over here that is marked up in a slight red. And that means that the system believes that the claim is probably incorrect, inconsistent with data. All right, let's have a look at this. This claim states that in the year 2016, 56,033 coders participated in the survey. Now, if I hover over this claim, it tells me the system believes that this claim can be translated into a query which simply counts all the elements, meaning all the rows in the data set. And since every row corresponds to the answers of one participant, this interpretation of the claim is actually correct. So indeed, there seems to be an inconsistency. The text claims we have 56,033 coders, while the data set only has, and you see that over here, 56,030 rows. So there seems to be some slight inconsistency. That's maybe not a big deal, but still it's a little mistake. And if that would appear, for instance, in one of the reports of the International Energy Agency or in other scenarios, that would actually be a problem. All right. So since the interpretation of the system seems correct and there's an inconsistency, we confirm, and now it is marked in strong red, meaning that the system now is sure that there's an inconsistency. We actually talked to the authors of that article at Stack Overflow, and we verified with them, and they confirmed that this was indeed a mistake. The problem was that the text was already published, and later the data set was still updated a little bit by deleting some inconsistent, some rows that I wanted to get rid of. And that led to the text and the data getting slightly out of sync. All right, let's look a little bit further. Here, for instance, we have the claim that I have shown before about the mobile developers for iOS. And this one states that 2.5% of the developers are iOS mobile developers, right? So if you still remember the data set that I've shown before, this seems to refer to the occupation column. Now, if I hover over this claim, I see first of all that the actual result of the query that the system translates the claim into, it's 2.45, but the system is smart enough to recognize that this can be rounded to 2.5%. It's doing that automatically. Also here, it's translated into a claim that can be evaluated as taking the percentage of rows where the occupation is set to mobile developer. That is close, but it's actually not quite correct, because here we're not talking about mobile developers in general, but about iOS developers specifically. Now, if that happens, I can click on View More Queries here, and then the system will show me the next most likely queries that it believes this claim can be translated into. So here those queries are already ranked by their probability to translate the given claim, and they're marked up in green or in slight red based on whether the query result, when evaluating on the actual data, actually makes the claim in the text, which you see here on top, true or not. All right, so here the most likely query sets the occupation to mobile developer. However, there's another query which sets the occupation to a mobile developer and iOS. So that is nearly the same, but something a little bit different. So this is the mathematical formula that this claim can actually be translated into. So I mentioned quickly at the beginning that the more technical term for those mathematical formulas is actually query. And here this tool uses this more technical term. All right, so now I select this query because that seems to translate the corresponding claim. And now it is marked as verified. If I look at the other claims, here I have a claim about mobile developers that are Android mobile developers. And here, yeah, we are setting the occupation to Android mobile developers. So that interpretation is correct. Here we have a claim about how many responses were received from Windows Phone mobile developers, which is 59. And that translates into a query counting rows where the occupation is set to mobile developer Windows Phone. All right, so I confirm that interpretation. And here there's the corresponding percentage. Here occupation equals mobile developer Windows Phone. And we're talking the percentage of rows. That seems correct. So I'm confirming this as well. So here I have fairly quickly verified a couple of claims that would have been potentially tedious to verify when using more traditional interfaces. So that is a little demo of the system. Now let's see how this actually works in the background. All right. Now let's first of all see the challenges that we are facing here. If we're just considering the simple claim that we started with, it's a claim about the beer consumption in different countries. And one first little problem that appears is already that you might find different terms, different terminology in the data set and in the text. For instance, in the text, we are referring to US, while in the data, we might be referring to American. So that means the system has to be able to find out if different terms refer to the same entity, if they're synonyms or otherwise related. Now, another challenge is that we might actually have multiple claims in the same sentence. So this second sentence here talks about beer averages in Germany and also in the US. We have two claims in the same sentence, one of which might be true while the other one might not be true. We can't be sure. So the system needs to be able to figure out which part of the sentence refers to which of those contain claims. And also, if you look at the second sentence alone, it actually doesn't mention beer at all. So in order to interpret that the second sentence actually refers to the beer consumption, we need to consider the first sentence and we need to use the context that already appears in the first sentence about the beer consumption. So the system needs to be able to link sentences to their context. All right. Due to all of those challenges, it is actually very hard to do this, which is fully automated verification. So that would mean that we translate the claim into a formula, we evaluate the formula, and then we say yes or no, whether the claim is true or false, based on whether the formula checks out or not. The problem is that this translation may go very wrong, and then our verification results are incorrect. And due to all of those challenges, it is difficult to get it right in every case. So probably this setup is not realistic. That is why we are focusing on semi-automated fact-checking instead, which essentially means that the system only translates the claim into a probability distribution of formulas. And then we bring the human into the loop, the human fact-checker in front of the computer, in order to verify the interpretation of the system, or maybe to correct mistakes if necessary. You have seen in that demo that most of the time the system actually proposes the correct formula first, but there is cases where it doesn't, and then we might want to select one of the other formulas instead. And then based on the feedback from the user, we can select the right formula and come to a verification result. Now, still, that leaves the problem, how can we come to this probability distribution over formula? So for one claim, we basically want to say, how likely is it that this claim translates into this formula on the data set? And we will exploit that in order to decide in which order we want to show those formulas to the human fact checker. Now, first thing we do is we analyze the data set. Now we look for interesting terms that appear somewhere in the data set, and we extract them from the data set. And then we use natural language processing resources in order to link those keywords from the data set to synonyms or other related keywords. And then we check whether those keywords appear somewhere in the text that we want to verify. And that gives us a very first intuition for which data specific claims refer to. Now, this is relatively coarse-grained. Of course, we have to look closer. We have to look at the specific sentences in which the claim we want to verify appear. Now, fortunately, there's nowadays a lot of sophisticated natural language processing tools available, which analyze the structure of those sentences at a very high degree of detail. Now, I'm not going to go too much into detail here, but you just see that we have a result which links different words in the sentence and says how one word relates to the other one. And we can exploit that, for instance, if we have claim values that appear in this text, as well as keywords that appear in the text. We can analyze the sentence structure in order to see which word relates to which claim. And in that way, we can deal with situations, for instance, where we have multiple claims in the same sentence. Now, considering the claim sentence alone is not enough, as we have seen in the previous example. You might have to consider the surrounding paragraph, you might have to consider the surrounding section or even the surrounding chapter. And our system does this. It considers the structure of the input text document, and when verifying a claim, it searches for interesting keywords that hint at the possible translations, not only in the sentence, but also in the context of the claim. And finally, it can be very helpful if you try to understand not only the document, but also the author of the document. Now, if we can somehow find out what the primary intent was when writing this document, what the author of the document wants to convey to the readers, then it can help us enormously in reliably translating the claims into formulas. So let's assume that we have translated the claims in the text into some formulas. Let's say we have a tentative translation. Then we can use our hypothetical translation, or hypothesis on how claims translate into formulas in order to infer what probably was the topic that the author wants to talk about, like which parts of the data set the author is focusing on, which aggregation functions the author is mostly using, and so on and so forth. Now, if we have formed a hypothesis on the topic, we can in turn use this again in order to make our translation from claims to formulas more reliable. So we can iteratively refine our hypothesis on how claims in the input text translate into formulas, and our hypothesis about what the main topic of the document is. So you can do this iteratively, always using the output of the previous stage as input to the next stage. And in our paper, we showed that this approach actually significantly increases the accuracy of the system. Quickly going to give you an impression for how that comes into play, going back to our demo here. All right, so we have quickly seen the statistics before. Here, for instance, I have information about how many of those iterations the system has performed. It was 4 in this case until convergence. And here at the bottom, I can see what information the system has inferred about the topic, meaning about which aggregation functions and which parts of the data set seem to be particularly important to the author of the text. And for instance, when it comes to aggregation functions, it seems that percentages are very popular for that author. So we can exploit that assumption when trying to map claims to formulas, and averages are also quite popular. Or if we look, for instance, here we see that claims which involve the occupation of developers seem to be particularly popular as well. All right, let's go back to the presentation. All right, good. So that is the system, the Act Checker system, which takes as input a text document with claims to verify. It consults a data set in order to verify them, and it acquires feedback from the human user in order to verify its assumptions. And internally, it uses modules for data, text, and topic analysis to come to a final verification result. Now, we have evaluated the accuracy of the system using a mix of newspaper articles from data journalism venues, using Wikipedia articles, and so on and so forth, everything which can be verified from data. This is an average of the claims we found in about 50 articles. And in this summarizing plot on the x-axis, you see how many proposed formulas from the system we are considering. You have seen in the interface that I can get ranked formulas from the system in the order of the probability that they correspond to the claim that I'm currently verifying. And here on the x-axis, we are varying how many of those formulas we are considering. On the y-axis, we see the percentage, like the chance that the right formula is among them. And here we see that, for instance, when only considering the 5 first formulas that the system proposes, we have a chance of something between 2/3 and 3/4 that the right formula is among them. And that seems impressive, given that typically for each claim, we have billions of possible formulas at least. Now, the fact that we get this precision, that seems to motivate some kind of automated verification support in those scenarios. On the other side, the fact that we are still a little bit away from the 100% for those more complex claims, it motivates that we want to integrate feedback from human fact checkers nevertheless. Now, if you're aiming for semi-automated fact checking, which we do, the right metric is probably that we want to save time for the fact checkers. And we performed a large user study. You can find more details in the paper. So here I just provide you with the high-level summary, where we measured how many claims people can verify per minute with and without our tool. So instead of our tool, they would be using, for instance, visual interfaces, spreadsheet software, or SQL interfaces. But in all of those cases, using our tool is significantly faster than not using it, leading to a speed up in terms of the claims verified per minute of a factor 6. So it seems that this tool can provide you with significant time savings. Now, we applied this tool in order to fact check a large range of articles. We were actually surprised by how many claims are incorrect. Often it's only rounding errors, so the claim value is still pretty close to the accurate value, but nevertheless it is wrong, and in certain contexts it is unacceptable. All right, good. So that is the first tool that I wanted to present. Okay, you're gonna have a look if anyone has questions, but that seems not to be the case. Good. All right. Now, the Act Checker system already works quite well. So it's the first system that we developed in this space. Now, after we had designed the system, we came across the use case of the International Energy Agency. And now it turns out that this design might not be sufficient in order to cope with that one. Because this system is currently designed for scenarios where we assume having a few pages of text to verify, which appears often but not always. We also assume that we can verify the text from one single data set, and that verification is done by one single person. But if you consider, for instance, the International Energy Agency, in that case, you would have large documents with many hundreds of pages to verify. You wouldn't verify using one single data set, but they have hundreds of data sets that are used for verification. And one single person is just not sufficient to verify all those claims. So we use an entire team of fact checkers. So here we very significantly need to scale up our approach. And this is what we have done recently with the scrutinizer system, which will soon be presented at the VLDB conference in a couple of months from now. And this system is optimized for dealing with fact checking at a much larger scale. Now, in the following, I'm gonna introduce you what are the main extensions of the scrutinizer system compared to the original act checker system. Now, the first additional challenge already is that we need to figure out which data a claim maps to. Before that was easy because we only had one single data set, but now we have to actually make a choice here. And the way in which we do this is by using machine learning. We're using a very powerful neural network, which has been pre-trained for general natural language understanding. And in order to use this network to map claims to the relevant data set or to the relevant data sets, because it might have to combine multiple data sets, we are essentially collecting training samples by asking the fact checkers questions about which data a claim relates to, and then we learn from their replies, so the system becomes more accurate as the verification process proceeds over time, even within the same document, if it is a large document. All right. Now, the next challenge is that we don't have a single fact checker, but we have an entire team of fact checkers. And in certain scenarios, such as for the IEA, it is actually insufficient to have one claim verified by one single fact checker, but we want to verify the same claim by multiple people, and we want to compare consistency among the verification results in order to be really sure that we have gotten it right. And in this case, we actually want to ideally to aggregate and to compare the verification results of different fact checkers automatically. But the problem is that if you allow those fact checkers to write free-form text, then it is very hard for the system to compare their reasoning in order to come to an aggregate result for one of those claims. So instead of allowing them to write free text verification reports, instead of that, the system rather structures the verification of one single claim into a sequence of relatively simple questions. And that makes it very easy to aggregate the results and to compare the results of different fact checkers. For instance, here you see this example interface from our prototype. Here we have a claim about the energy demand, and the number to verify that is 338 terawatt hours. Here the system just asks the fact checker which years this claim relates to. And you see some answer options at the lower half of the screen. Those are again ranked by the probability that the system believes this is the right year, based also on a machine learning method which calculates the probability for different answer options. All right. Now, in order to verify one claim, the system has actually lots of choice about what to ask to those fact checkers. For instance, the system can choose which questions to ask. It can choose which answer options to show and how many answer options to show. And typically, for verifying one claim, it is insufficient to ask one single question, but we typically want to ask a sequence of questions. And that gives us the choice to also choose the order in which we want to ask those questions. Now, that order actually matters because if we have an answer to one question about a certain claim, it can help us to narrow down and to eliminate certain answer options for later questions of the same claim, thereby making it fast and easier to answer those questions. Now, we use a mathematical model which estimates how long it takes to verify one claim given a specific sequence of specific questions, and we exploit this mathematical model in order to try to optimize the sequence of questions we want to ask about each of those claims, and that is implemented in this interface optimizer module. Now, finally, another difference is that now we are not dealing with a small document, but we are dealing with a very large document. That gives us a lot of choices about the order in which we may verify different claims in that document. And it raises the question which order we want to choose. In the simplest case, of course, we could just verify claims in the order in which they are given in this document. But maybe that is not the optimal way to go. Consider, for instance, again, those claims from those 2 pages that I have marked up over here. I have told you before that we have a mathematical model estimating how long it takes to verify certain claims. Now, this value may actually change over time for the same claim because the system learns during the verification. So over time, it will become more accurate in mapping claims to the right data and to the right formula. And if it already suggests the right options to the fact checkers, then it becomes much faster to verify those claims. So what we could do is that we just use those cost estimates in the sense of time used for verification for each of those claims. And we start by verifying the cheapest claims first in the hope that the other claims will become cheaper as verification proceeds and the system learns to become more accurate. Now, on the other side, there is another criterion, which is that different claims may be differently interesting to different degrees for the system to learn from. For instance, if you are verifying a claim which is very similar to other claims the system has already seen, it won't learn a lot, so the accuracy won't prove so much. On the other side, if the system gets a verification result for a claim which is very unusual and very different from the claims the system has seen before, then it actually might be very interesting to increase accuracy. For the machine learning practitioners among you, what we're doing here essentially relates to what is typically termed active learning, where the system has a certain amount of choice about what it wants to learn about first. So if we express the degree of curiosity the system has about different claims here by those question marks, we could take that into account as well in order to order our claims in the ideal order. Now, of course, on the other side, it might be very inconvenient for the fact checkers to verify claims that are randomly distributed in some multiple hundreds of pages document. So we also want to take into account the structure of the document and try to minimize overheads related to getting into a new paragraph or getting into a new section of the report in order to verify the contained claims. And we take all of those factors into account in order to come to an optimal compromise when ordering those claims. And that is done by the so-called claim ordering module. So this is a very high level overview of the system now. On our website, you find the paper which has all the technical details. I'm also happy to answer questions about the technical details later. All right. So now, we did a user study with the fact checkers at the International Energy Agency when using the system. And we found that the speed up when using our tool versus using the traditional fact checking process is more than factor 2. And that is actually very promising results in my opinion, particularly since here we are working with professional fact checkers. We have a lot of experience with the process that they have already been using over the past years to verify those reports. On the other side, they don't have experience yet using our tool. And nevertheless, even taking this into account, we're already able to show a speed up in verification. Now, this is the first use case to which we have applied the scrutinizer tool. Also, we have applied the system in order to verify statistical claims about the coronavirus, as I have quickly mentioned before. So here we want to quickly see the corresponding interface, and you also find the link over here. Let's, for instance, try the claim number of confirmed cases, which in this context, corona cases, in Germany is higher than in Switzerland. But two countries that I have connection to, and Germany is larger. So let's see whether that actually checks out. And here, actually, all right. So here, if I add the total, then it verifies this claim by translating it into a formula A greater than B, which evaluates to true. Here it maps the claim to the corresponding data about Germany and the corresponding data in Switzerland. All right. And every once in a while, as you have already seen before, the system will pop up a little dialogue asking the people using the system to verify whether its interpretations are correct or not. And if that happens, the system puts it into a database and learns from that over time. So this system was actually recently covered in the press, including, for instance, Corriere della Sera, which is a national newspaper in Italy. And we have received over 12,000 distinct users so far, which is pretty good for a research prototype. All right. And before I conclude here, because I'm running out of time, I want to thank my entire team and our collaborators who have made this research possible. Those are my PhD students, Ehan and George at Cornell, as well as several amazing undergrads, and two amazing collaborators at Google, Kong Yu and Xueqi Wang. Google is also funding this research. I'm very happy about that. And then our two amazing collaborators at Eurecom in France, Professor Papotti and Mohamed Said. So in conclusion, this talk was about data-driven fact-checking, for which there are various use cases, and I've presented two tools. First of all, the Act Checker system. The final paper on the system appeared on SIGMOD 2019. The first paper already appeared in 2018. And our latest system in this space, that's the Scrutinizer system, which is about to be presented at ELDB 2020. So thanks for joining here. I'm happy to take a few questions now. Otherwise, if you want to know more about our work, please visit our website at itrauma.org or shoot me an email at itrauma@cornell.edu. And now I just saw there is some messages in the chat, so let's see whether there is any questions here. Okay, the question is whether I can share the slides, and yes, that is possible. All right, and we are already at the allocated time limit. So I'm very happy to take more questions later via email. Is there any more questions here for the moment? All right, all questions answered. That is amazing. Nobody, any questions? All right, good. Then, oh yes, okay, here there is a question. All right, let me quickly. Thank you. Okay, here I'm actually, okay, so I'm allowing participants to unmute themselves. That might be easiest.
Hey.
Hello, whom am I talking to?
My name is Joaquin. I'm from Chiquiado, Argentina. So
very nice
yeah,
to meet you.
Nice to meet you too. It was a lovely presentation. Really,
thank you.
A handful of insight into what you're doing, and it's really amazing. My first question that is really reliant on, well, from where we are working is how dependent is your models and stuff on the language in particular? Now, how attached are you to the English language?
Okay, good point. So, I mean, in principle, the methods that I have presented they should be applicable to many other languages. Our Act Checker demo currently is available only in English, but for instance, our web interface for fact-checking Corona claim is already available in multiple languages, in English, French, Italian, German, and I think might actually have expanded it further. So nowadays there's a trend in natural language processing towards models that up to a certain extent abstract away from the concrete language that is used. So yes, this should generalize to many other languages.
Cool. So it's not that you're translating the claims to English and then solving them in English, but you are using NLP models that support multiple languages at the same time.
Exactly. There's nowadays models, pre-trained models, for instance, by Facebook, which actually cover multiple languages. And for that web interface, we're using one of them.
Cool. And thanks.
Sure. Happy to. All right.
One other question.
Yes, please.
Yeah, I'm wondering, do you envision these tools that you're developing ever being used on social media to help identify false claims?
Sure, that would be, of course, a very interesting application scenario. And we are currently looking at this. So yes, I mean, one of the nice things, I mean, if you have an entire document, there are certain things that you can do, which you cannot do if you have one short tweet, for instance, trying to analyze the document structure and the topic of the document. But sure, nevertheless, I mean, we are definitely looking at social media as an application scenario. For instance, for this most recent work, I mean, we are also verifying single sentence claims. So that would make it applicable to social media platforms.
Thanks.
Sure. So, and here is the question whether the tool is open source. So currently the demo is available publicly, so you can check it out. You can upload your own text. You can upload your own data in order to verify, so you can freely try it out. Currently, we are working on publishing. The code is not yet available online. For the most recent tool, that one is already publicly available. Yeah. And another question is, can the system also read from PDFs? Reading from PDF, that would require a step which translates, which essentially extracts claims from the PDF document. But so I don't see any technical challenges there. We haven't implemented that yet, but it should be fairly straightforward to do actually. I mean, as soon as you have the text extracted and there's standard tools which extract text from PDF, then you can just apply the approach that I have shown before.
Is it challenging to identify claims within?
Well, claim identification is like a research topic all by itself. So yes, it is challenging. There has been some dedicated work about it, for instance, in the Claimbuster system in identifying check-worthy claims. So right now we are focusing more on verifying claims. In this demo, I quickly have shown how the system heuristically identifies things that look like they might be claims that it can verify from the data. So we are using a mechanism there, but we do rely on the user of the system in order to confirm what the system thinks about what should be verified.
Okay.
Any more questions? Okay, some people want to.
I'll just chime in and say that I think it was a great presentation. I think there's a lot of use. Love to talk about how we can integrate the tool with Check, and had a long-standing interest in mapping, crosswalking from queries into structured data sets.
Yes.
So if you think about the claims that you generate out of the structured data as having a relationship to a prospective claim, I think that that can also be derived programmatically, and then that can be clustered against natural language expressions.
That's a good point. So you're talking about like clustering similar claims together and then trying to translate them together?
Exactly. Yeah.
Exactly, yes. That is a great point. And I think there's like a lot one could experiment with in this direction. Up to a certain extent, what we're doing currently, we essentially linking together claims which essentially appear in the same document. So up to a certain extent, we exploit some similarities between those claims. But there's other ways of doing this, perhaps also more explicitly, and I agree that this would be a very interesting direction. Okay, and here the question is, does the system only work on mathematical computations or also with text? So, we are using text as input, and then the system translates it into a mathematical formula. So I'm not sure whether you are talking about claims which are not really statistical in nature. For instance, for the coronavirus, there is some claims about certain cures which often don't work. For instance, eating silver particles might cure the coronavirus. For instance, actually, we have other systems which address those scenarios. Perhaps I can even very quickly show one of them. But yeah, so this system focuses on claims that can be verified by translating them into formulas on structured data. So that we are doing a couple of other projects around fact checking. So here I have focused on the data-driven fact checking, but let me see. Right. So I'm sharing my screen again. Quickly show this. Right. So here we have the a fact-checking tool for non-numerical claims about the coronavirus. We will put the link on our website within the next couple of days. But here, for instance, if you try something like this, then the system uses a neural network in order to try to link this claim to existing fact checks, which confirm that this might not be a thing that you want to try. So there's different methods that we can use for different types of claims. Now, the things that I have presented during most of the talk, those are claims which can be verified by translating them into mathematical formulas on structured data. For different claims, you might want to use different tools. Right. Any other questions?
Yes, about the last feature you showed. I'm Emmanuel Vincent from Science Feedback, a fact checker verifying.
Nice to meet you.
Nice to meet you. And thanks for the presentation. So we are verifying claims about science, health, and climate change mostly. So I'm interested in the last feature you showed about finding fact checks related to a given claim. Is that feature operational? Or I guess not yet, but yeah, well, will it be usable?
I mean, we have a prototype, and so I wanted to put a link to the demo online within the next couple of days. but that's something that we are still working on. But I mean, in those cases, it already works. So yeah, prototype operational.
Okay, that would be useful for us.
Awesome. Okay. And I mean, if you think in general that any of those things, they might be applicable to any of your use cases, I would be very happy to get feedback. In general, if you believe that you can use one of the existing tools that I have presented, but also if you believe that you need some new features in the domain of automated fact checking for your scenario, I would be very happy to link up and to see whether we can do anything about that.
Okay, I'll send you an email.
Thanks.
Thanks.
Okay, awesome. Yes, I'm very happy to check out. I'm getting links to groups and for collaborations. I'm very happy to check that out and to sync up on that. Thank you. Okay, any other questions? We're already a little bit above the time. I'm sorry for that. Good. All right. Thanks a lot for attending. Very happy to sync up and have a great evening.
Thank you.
Thank you.
Thanks. Bye-bye.
Bye.